The integral should be this. The integral from minus infinity to 0, minus infinity to 0, just watch patiently, I'll show you the shortcut. 0 to 2, then 2 to infinity, that's it. This should be the structure of the integral, the limits, upper and lower limits. From minus infinity to 0, the function is equal to what? 0. But see, otherwise it means that if it is not in 0 to 2, it is 0. That's the meaning. So only 0 to 2 is half. Outside this, it is what? 0. So my f of x will be 0. X is still x. F of x will be 0 dx. Then from 0 to 2, inclusive we have 1 over 2. This is x, right? Into f of x is what? 1 over 2. 1 over 2 dx. Then from 2 to plus infinity we have 0. Because it's outside 0 and 2. So we have x. X is always there for expectation. Then this is 0 dx. But do you know what? 0 times x is 0. Everything here turns to 0. You know what? 0 times x is 0. Everything here turns to 0. So in actuality, if I am doing expectation, I don't have to go over the full real line. If it is like this, if the function is stated like this, like they said, they gave me a function in one interval, they now said 0 otherwise. So what that means is that I should just integrate from 0 to 2, finish. I don't have to go from this to this, and this to this, this to this, because this one will give me 0. You get it? Let's now talk about the mathematical expectation of a random variable. The previous video was on random variables as well, but there we emphasized or we talked about the probability mass function of the discrete random variable and the probability density function of the continuous random variable. In this video, we are going to talk about the mathematical expectation, or we can say the expected value or the mean of a random variable. For the discrete random variable, what is the mathematical expectation? If x takes values x1, x2, x3 up to xn, with probability that x takes on the value x. You know, this is the probability mass function for each of the x. Alright? The expected value e of x, this is how I write it, capital E of x. You know, capital X is the random variable, then the small letter x is the value that that random variable takes. It is equal to the summation of each x multiplying the corresponding probabilities. This is the expected value. Now, we also need to do expectation of x squared most times. When we want to calculate for the variance and the standard deviation, we need this. But this one is standard, okay? We always need this. This is a summation of x squared into p of x. So this is it for the expectation or the mathematical expectation of a discrete random variable. What is it for the continuous random variable? For a continuous random variable having a probability density function f of x, the expected value of x is defined as, you know, for continuous random variables we deal with integrals. So expectation of x for a continuous random variable is the integral from minus infinity to infinity of x multiplying the density function dx. Then expectation of x squared is the integral from minus infinity to infinity times or of x squared into the density function dx. So this is it for the continuous random variable. There are some things about mathematical expectation that we should know. One of them is that the expected value of a constant, e of c, let's say c is a constant, it is the same as the constant. So the expected value of a numerical value, it is also the value. Now, the expected value of the sum of x and y, two random variables, is the sum of the individual expectations. That is it. Expectation of x plus the expectation of y. Also, the expectation of two random variables that are independent, that is the product of x and y, expression of x times y, is actually expression of x times the expectation of y. In this case, x and y are independent random variables. So we could say for linearity property that the expectation of a constant a into the random variable x plus another constant b, what would this be? This is equal to a expectation of x plus b. This is it. If I have the expectation of ax plus b, you know that a is a constant, b is a constant, x is the random variable. So this will give me expectation of ax from theorem 2 plus expectation of b. And we said that the expression of a constant is actually a constant. A is a constant, so a can actually come out to give us a into the expression of x plus the expression of a constant is still the constant from theorem 1, that's b. That's how we got this. Alright, so let's talk about variance and standard deviation. So for the variance and the standard deviation of a random variable, variance of x, okay, is a shortcut formula. It is expectation of x squared minus the expectation of x all squared. That's the formula. Expectation of x squared, you know we've done that before. We got it here, and we got it here also. Alright, minus the squared of the expectation of x. Then standard deviation of x, or we use the symbol sigma sub x. The symbol was standard deviation. You know, standard deviation is the square root of variance. It is always the square root of variance. So it is the square root of the variance of the random variable x. So we will need these formulas, these theorems to solve questions on mathematical expectation of a random variable. Watch this video to the end. It's very important. All right. Subscribe, like, and share this video to your friends and to your classmates. Let's dive right in. Let's handle the first question. A biased four-sided die has the following probability distribution. Calculate the expected value as expression of x and the variance of x. Alright, it's easy to do. This is a discrete random variable. Yeah, it's a discrete random variable. And remember, for a discrete random variable, the mathematical expectation is the summation of all x into probability of x. So what I'll be doing here in simple terms is multiply each of the x with the corresponding probabilities and add up the results. That gives the expectation. So this is the expectation of x here is 1 into 0.1 plus 2 into 0.2 plus 3 into 0.5 plus 4 into 0.2. Add up these values. This is 1, this is 0.1, 2 times 0.2 is 0.4, this is 0. Oh, this is 1.5, 15, 1.5, this is 0.8, 0.1 plus 0.4 plus 1.5 plus 0.8, that's 2.8. So the expected value is 2.8. Okay, now they are asking for the variance of x. The formula for variance of x, if you remember the formula I gave, variance of x, okay, is the expected value of x squared minus the square of the expected value of x minus. So the question is, what is the expected value of x squared? Because I have expression of x already as 2.8. So what is this? Now let me calculate for this. For the expected value of x squared, You always need this one for variance, all right? Expected value of x squared is simple. What we did for the expected value of x was we multiplied each of them, right, and added them together. We got 2.8. For this one that has a square, you square each of them first before you multiply. What's 1 squared? 1 squared is 1. That's 1 into 0.1. 2 squared is 4. 4 times 0.2. That's 4 times 0.2. 3 squared is 9. Are you there? 9 times 0.5. 4 squared is 16. That's 16 times 0.2. That's how to do expedition of x squared. This will still give me 0.1. This will give me 0.8. This should give me 9 times 0.5. 9 times 0.5. 4.5. 4.5. 16 times 0.2. 16 times 0.2. 3.2. So if I add up everything together, 3.2 plus 4.5 plus 0.8 plus 0.1 is 8.6. So we have 8.6 as the expectation of x squared. So the variance of x will now be this. This one is already 8.6 minus, what's the expected value of x? It is 2.8. 2.8. All right, so what's 2.8 squared? It is 7.84, right? 7.84. So if I say 8.6 minus 7.84, that will be minus 8.6. Okay, that's 0.76. That's it. Or 19 over 25. Yeah, it's equivalent to 19 over 25. So that's the variance of x. Then let's assume we are asked to also find the standard deviation of x. The standard deviation of x is the square root of the variance of x, which is the square root of 19 all over 25. This is root 19 all over 5. That's the standard deviation of x if we are to calculate for it. Question 2 is still on discrete random variable. From question 3, we have questions under continuous RV. All right, we are given a random variable with the values x, minus 2, 3, and 1 with their corresponding probabilities. And the question is asking for expedition of x, the expected value of 2x plus 5, and the expected value of x squared. Simple, let's go ahead. The expected value of x is this. Multiply each of these x with the probabilities. Minus 2 times 1 over 3 plus 3 into 1 over 2 plus 1 into what? 1 over 6. This is minus 2 over 3, right? Minus 2 over 3. This is 3 over 2. This is 1 over 6 plus 3 over 2, 1 over 6. What's the LCM of 3 to 6? The LCM is 6. 6 divided by 3 is 2. 2 times minus 2, minus 4. 6 divided by 2, 3. 3 times 3 is 9. 6 divided by 6, 1. 1 times 1, 1. 9 plus 1 is 10. 10 minus 4 is 6. 6 over 6 equals 1. This is the expected value of x. For the second part, we are asked to find the expected value of 2x plus 5. We will use that expected value theorem for addition. If you are adding or that linearity property is the same thing. Recall we said that the expected value of x plus y is actually expected value of x plus the expected value of y. And for linearity's sake, if we have the expected value of x of ax plus b, which is the expected value of ax plus the expected value of b. And this is actually equal to a, you remember, into the expected value of x plus b. Because b is a constant, the expected value of the constant is a constant, then a is a constant here, it will come out. So what this means is the expected value of 2x plus the expected value of 5. And this is actually 2 into the expected value of x plus 5, right? So what is the expected value of x? It is 1. So this is 2 times 1 plus 5. 2 times 1 is 2. All right, what's 2 plus 5? 7. So this is equal to 7. For the last one, what is the expected value of x squared? The expected value of x squared is simply, all right, we'll square each of these values and multiply them by their corresponding probabilities. Minus 2 squared is 4. 4 times 1 over 3 is 4 over 3. 3 squared is 9. 9 times 1 over 2 is 9 over 2. 1 squared is 1. 1 times 1 over 6 is 1 over 6. What's the LCM? LCM is 6. 6 divided by 3, 2. 2 times 4, 8. 6 divided by 2, 3. 3 times 9, 27. 6 divided by 6, 1. 1 times 1, 1. This is simply 36 over 6. And that's 6. So the expected value of x squared is 6. While the expected value of x is 1. Whereas the expected value of 2x plus 5 is 7. So you can do the variance and the standard deviation of x from here, although we were not asked to calculate for it. Expected value of x squared is 6, of s is 1. So what will be the variance? The variance will be, the variance of x will be this, which is 6, minus the square of 1 square, and that's 5. That will be the variance of x. And the standard deviation of x will be the square root of 5, which will be what? Root 5. So that's it for this particular question. We cannot call it a wrap without talking about continuous random variables, the expected value of a continuous random variable. While watching, share the video with your friends, like the video, and subscribe. Very important. This is where the whole matter lies. Continuous random variables. It is easy to do for discrete random variables, but because there is integration involved in continuous ROV, it's sometimes a problem for students. But don't worry, I am here. I'm going to break it down. So yours is to watch patiently and keenly so you understand everything I'm going to say. I will invoke some principles of calculus here, even if you've not learned calculus before, but you can still follow. All right, let's go. This is on continuous random variables. The first two questions were under a discrete random variables. At the end of this video, I'm going to drop a question for you to solve. So watch to the end so that you can solve the question. And when you're done with the question, you drop the answer in the comment section and I'm going to review it. Let x be a continuous random variable with probability density function f of x equal to 1 over 2. For 0 less than x less than 2, for 0 less than or equal to x less than or equal to 2, and 0 otherwise. Calculate the expression of x and the variance of x. This is a continuous random variable that can be written like this. F of x equals, is a piecewise function, a pieces of two functions, let me say like that. One of them is 1 over 2, and for 1 over 2 we have 0 less than or equal to x less than or equal to 2. Then I said 0 and 0. 0 is here otherwise. Alright, let's go with the first one. What is the expectation of x? Solution. For a continuous random variable, the expectation of x is the integral from negative infinity to positive infinity of x into f of x dx. Alright, don't panic if you are not good at integration. I will show you the way around it. Actually, when we are integrating or when we are dealing with continuous random variable, we are integrating over the whole real number line from minus infinity to plus infinity. But there will be no need to do that in this case because one of the functions is 0. Listen up. The functions that I have here, we have this, two functions. So I'll be having two integrals like that. But let's see if it's going to be two integrals in real life. Minus infinity to infinity means the full real number line. In real numbers, the whole set of numbers is written in one interval like this, minus infinity to plus infinity. So all numbers like they lie in this interval. The function is equal to 1 over 2 between 0 and 2 inclusive. And outside 0 and 2, it is 0. I have, in the real number line, we have minus infinity, we have plus infinity. Then they gave me 0. I'm just trying to explain because I like when students understand the foundation of something. This is 0, right? Then to the right, we have 2. Assuming this is the structure of the number line. We are coming from negative numbers, you get to 0, you get to 1, 2, you keep going, right? So they are telling me that in this interval, 0 to 2, the function is 1 over 2. Then outside this one, outside this, it is 0. That's the meaning. This is how we integrate it. The integral should be this. The integral from minus infinity to 0, minus infinity to 0. Just watch patiently. I'll show you the shortcut. 0 to 2. Then 2 to infinity. That's it. This should be the structure of the integral, the limits, upper and lower limits. From minus infinity to 0, the function is equal to what? 0. But see, otherwise means that if it is not in 0 to 2, it is 0. That's the meaning. So only 0 to 2 is half. Outside this, it is what? 0. So my f of x will be 0. X is still x. F of x will be 0 dx. Then from 0 to 2, inclusive, we have 1 over 2. This is x, right? Into f of x is what? 1 over 2. 1 over 2 dx. Then from 2 to plus infinity, we have 0 because it's outside 0 and 2. So we have x. X is always there for expectation. Then this is 0 dx. But do you know what? 0 times x is 0. Everything here turns to 0. You know what? 0 times x is 0. Everything here turns to 0. So in real life, what am I saying? In actuality, if I am doing expectation, I don't have to go over the full real line. If it is like this, if the function is stated like this, like they said, they gave me a function in one interval, they now said 0 otherwise. So what that means is that I should just integrate from 0 to 2. Finish. I don't have to go from this to this, and this to this, this to this, because this one will give me 0. You get it? What you will do if you are solving a question in the exam or you are solving on your own, we already know that since we have otherwise and the function is 0, this one will give me 0. So just go straight to this. Just do this one and you are there. So this is equal to the integral from 0 to 2 of x. What's x times 1 over 2? It is x over 2. Wait, let me write it as x times 1 over 2. I'm assuming you don't know integration in this case. In integration, 1 over 2 is a constant. X is the variable. The constant can come out. It will be 1 over 2 to the integral from 0 to 2 of x dx. Okay, fine. So the constant is out. I want to integrate x with respect to x. All right. What we'll do next is this. This is 1 over 2. The rule of integration says that if I have the integral of a function ax raised by n dx, this is the rule of integration. You must know this. It is write the a, write the x, write the n, then add 1 to the power. Are you there? And divide by that n plus 1. Then add a constant of integration to it. That is, the integral is not definite. You see this particular integral that runs from 0 to 2? If it has something like this, 0 to 2, we call it on the lower limit and this on the upper limit. This one does not have lower and upper. It is called indefinite integral. But if it has lower and upper limit, it is a definite integral. For definite integrals, we don't need constant of integration. But for indefinite integrals, we always write the arbitrary constant, C or K, whatever it is. That's the rule. So this x here is carrying the power of 1. So if I want to integrate x, it's going to be s 1 plus 1, 2, all over 2. True or false? True. That's the rule. Then the integration is going from 0 to 2. I will not be writing c because it is definite. I will just write from 0 to 2. From s equal to 0 to s equal to 2. So this is 1 over 2. Now, I'm here. What I will do is this. This is s squared over 2 from s equal to 2. Sorry, from s equal to 0 to s equal to 2. 2 is the upper limit. Plug in the upper limit first. This will be 2 squared minus, 2 squared over 2. I've plugged in the upper limit. Then the rule says now do minus. Plug in the lower limit. 0 squared over 2. 0 squared over 2. I have videos for integration you can watch. In fact, the basics, everything behind the basics, from definite integrals, indefinite integrals, by parts, by substitution, by partial fractions, they are there. In the playlist of calculus, you will find the videos. So you can watch to understand the calculus behind what I'm doing. So we have 1 over 2 into, what's 2 squared? 2 squared is 4. 4 over 2 is 2 minus, of course, 0 over 2 is 0. So this is actually 1 over 2 times 2, and that's 1. You know, for variance, I need expression of x squared. The expectation of x squared will be the integral from minus infinity to infinity of x squared into f of x. For expression of x, we use x. For x squared, we use x squared times f of x dx. This is equal. Based on what I did before, I don't want to go from here to here, from here to here, from here to here. The control will give me 0. This one also give me what? 0. I'll just take this. The integral from 0 to 2 of x squared into the function of x, and that is 1 over 2. 1 over 2 dx. So bring down 1 over 2. This is 1 over 2 into the integral of from 0 to 2 of x squared dx. X squared dx. So if I integrate x squared with respect to x, that would be 1 over 2 into the integral. Oh, sorry. I should be removing integral now if I want to integrate. You get it? This is 1 over 2 outside. Integrate x squared by the rule. What will it be? This is 2. Add 1 to the 2. That will be 3. So this will be s cubed divided by that same 3. Alright. Then I will not be adding c now. I'll just say from 0 to 2. From 0 to 2. But there's something I didn't show you earlier. I didn't want to bother you with too many principles on that integration. There's a 1 over 3 here. It can come out. If it comes out, it will multiply this 1 over 2 outside to give me 1 over 6. What will be left here is now s cubed from 0 to 2. So plug in the upper limit, we have 1 over 6. 2 cubed is 8. 0 cubed is 0. So I'll be having 8 over 6. 2 into 8 is 4. 2 into 6 is 3. So the expectation of x squared is 4 over 3. It is very easy to solve questions like this, right? As you can see, it's easy. And I can tell you that this is the best video you'll find on YouTube as far as this particular concept is concerned. What is the variance of x? I've gotten this, so I can go straight now. The variance of x will be expectation of x squared minus the expectation of x. And what would that be? I've gotten this one as 4 over 3. Then that one is what just now? 1. 3 times 1 is 3. So I have 4 minus 3 all over 3. And that was 1. That's the variance of x. And let me do something extra in addition. The standard deviation of x, sigma sub x, is the square root of 1 over 3. Right? Because standard deviation is always the square root of variance. Let's quickly run through this. The last one. For a continuous random variable x with probability density function as shown below, We have to compute the expectation of x and the variance of x. Sorry, the standard deviation of x. Anyways, we will still need to get the variance before the standard deviation. True or false? True. Now, this is the PDF, the probability density function I'm giving for the continuous random variable. But the problem with this question is that there's an unknown value, which is k. I can't do anything without getting k. Although the question actually stated that we must find k first. But I know, as a student, I understand the principle behind it. You know that you must get k first before proceeding to calculate for this and this. The almighty question is, how do we get k? What principle of expectation or whatever can help us find k? To get k, we are going to take our mind back to video 1, when we said that for probability, generally, the sum of all probabilities is equal to what? 1. So I will integrate this function in this interval, integrate this one in this interval. Of course, 0 is 0. We neglect it. You understand now? Then set everything, the sum of everything to 1. Look at it. For a continuous random variable, let me use this CRV. The integral from minus infinity to infinity of f of x dx equal to 1. That's the density function. It is a property of continuous random variable. So I'm going to add up everything here. Integrate this. This is the integral from minus 2 to 0 of what's the function? We have k into x plus 2 squared dx plus integrate this. The integral of 4k from 0 to 4 over 3 is 0. Okay, 4 over 3, 4k dx equals 1. Alright, let's go. K is a constant, it will come out. This is integral from minus 2 to 2. Let's expand this one. This is s squared plus 4s plus 4. Then this is 4 is the constant, k is a constant. They will come out. We have from 0 to 4 over 3. Then what's left there? Dx equals 1. So this is k. So let me integrate each of them. Integrate s squared, we are going to get s cubed all over 3. Remember, integrate 4s, we get 4s squared over 2. This will give you 4x from minus 2. Oh, sorry, this is not 2, this is 0. From minus 2 to 0. Yes, minus 2 to 0. Then plus, this is 4k. If I integrate the s, I'll get x. So the x from 0 to 4 over 3 equal to 1. So this is k into, we'll now plug in the upper limit. Plug in 0 for x here. Everything will be 0, 0, 0. That's 0. Minus, plug in the lower limit. You know it is upper limit minus lower limit. Minus 2 here is minus 8. So we have minus 8 over 3. 4 over 2 is 2. 4 over 2 is 2. Minus 2 squared is 4. So 2 times 4 is 8. Then 4 times minus 2 is minus 8. This one is for the first one. Then you come here. This is 4k. Plug in 4 over 3. That's 4 over 3. Minus plug in 0. That's 0 equal to 1. So this is k into 8 minus 8 is 0. Minus times minus will give me a plus. So that will be 8 over 3 left there. 4 over 3 minus 0 is 4 over 3. 4k times 4 over 3. That will be 16k all over 3 equal to 1. K is common to the two of them. I will just bring k out, open one bracket. I have 8 over 3 left here. Then I have 16 over 3 left here, right? 16 all over 3 equal to 1. Okay, 8 plus 16 is 24. Since they have the same denominator, I can just add them up. The numerators, 8 plus 16, 24. So it means that k into 1 over 24 over 3 equals 1. 24 over 3 is 8, so this is 8k equals 1. Divide both sides by 8. It implies that k is 1 over 8. So k is equal to 1 over 8. Let me write that value somewhere. The value of k is 1 over 8. K equals 1 over 8. So we can proceed to determine the expected value of x and the standard deviation of x. Expected value for a continuous random variable is the integral from minus infinity to infinity of x into the density function of the distribution dx. So I should be saying this integral will span from, I will be taking these two functions, excluding this last one because it's 0. So we have the integral from minus 2 to 0, x of x into the function is k into s plus 2 squared. But what's k? K is 1 over 8. So I'll be writing times 1 over 8 into s plus 2 squared. Alright, dx. Plus, I'll take the next one. The integral from 0 to 4 over 3. 0 to 4 over 3. Then I have 4k as the function. Then it is x times 4k. So x times 4k, but k is 1 over 8. So this is times 4 times 1 over 8 dx. So this is the integral from minus 2 to 0. I told you that if I have a constant like this, I can factor it out. This one will be 1 over 8. So I'm having x into s plus 2 squared dx. Then here I have from 0 to 4 over 3. 4 here is 1, 4 here is 2. So what do I have? I have 1 over 2x there. Alright, 1 over 2. I can bring out the 1 over 2. I'll be left with x dx. You get it? So if I expand s plus 2 squared, it will be s squared plus 4s plus 4. Multiplied by the x outside, what will it be? It will be s cubed plus 4s squared plus 4x. So this function here will have 1 over 8 into the integral from minus 2 to 0 of s cubed plus 4s squared plus 4x dx. Then this is 1 over 2 into the integral from 0 to 4 over 3, 0 to 4 over 3 of x dx, s dx. Alright. If I integrate this, let me integrate these brackets. I have 1 over 8 outside into, integrate this, you get s to the 4th over 4. Integrate the next one, that will be 4s cubed, right, over 3. The next one is 4s squared over 2. From minus 2 to 0, then we have the next integral plus 1 over 2 into the integral from 0 to 4 over 3. But let's integrate x dx. You will get s squared over 2 from 0 to 4 over 3. So let's proceed. Plug in the upper limit for x. X here is 0, x here is 0, x here is 0. We have 1 over 8 outside. This is 0. Everything here is 0. If you plug s, then we say minus. Let's plug in the upper limit. Minus 2 raised to the power 4 is 16. 16 divided by 4 is 4. Minus 2 cubed. Minus 2 enter here give us minus 8. Times 4 is minus 32. So we have minus 32 all over the 3 under it. Minus 2 squared is 4. 4 times 4 is 16. 16 divided by 2 is 8. So we have plus 8. Plus 1 over 2 into, check, this 2 is inside the bracket. That integration, it can come out. It will multiply this one outside to give me a 4. So I'll be left with s squared inside the brackets. This is 4 over 3 as the upper limit, and this is 0. 4 over 3 will enter first. We have 4 over 3 squared, and that's 16 over 9. minus 0 will enter to give 0. So we have 1 over 8 into, this is 0 minus 4 plus 8 is 12, right? So we have 12 minus, okay, let's simplify this bracket. 4 plus 8 is 12. 12 minus 32 over 3. 3 times 12 is 36, so we have 36 minus 32 all over 3. All right, and what would that give me? That will give me 36 minus 32 is 4. Yes, this is 4 over 3. So inside this bracket, it is 4 over 3. But there's a minus outside, so it's going to be minus 4 over 3. Are you there? Then the other side, we have 1 over 4 into 16 over 9. 4 here is 1. 4 here is 2. 4 here is 1. 4 here is 4. So I'm having minus 1 over 2. Left, minus 1 over 6. Then 1 times 4 is 4, 4 over 9. The LCM of 4 and 6 and 9 is 18. 18 divided by 6 is 3. 3 times minus 1 is minus 3. 18 divided by 9, 2 times 4 is 8. So we have plus 8. 8 minus 3 is 5. So this is 5 over 18. Let's finish the calculation here. Okay, this is the function that we have. And we've solved already for the expectation of x, and we got 5 over 18. K was 1 over 8. The question is asking for, remember, the expectation of x and the standard deviation of x. And to get standard deviation, we need the expectation of x squared. All right, let's quickly find the expectation of x squared. It is equal to the integral from minus infinity to infinity of x squared into f of x dx. All right, so what would this be? This is the integral. I'll not be integrating over the full real line since this particular function is 0. So I'll just take this, I'll take these two. So let me take this one from minus 2 to 0, from minus 2 to 0. And the function is k into s plus 2 all squared. Then I'll take the second one, which is 4k. So the integral is from 0 to 4 over 3. 0 to 4 over 3. There's x squared here, sorry. Then I'll write my x squared into what's the function of x? It is 4k. So 4k dx. K is 1 over 8. All right, let's go ahead. So the expression of x squared is the integral from minus 2 to 0 of x squared into k is 1 over 8. That 1 over 8 can come out. All right. Then I'll be having x plus 2 squared dx. Then for the second integral, k is 1 over 8. So let me bring out that 1 over 8 outside. It's going to be plus 1 over 8 to the integral from 0 to 4 over 3 of remaining x squared and 4. So that will be 4 x squared dx. So this is 1 over 8 is common to both integrals. I can bring 1 over 8 outside and open the general bracket. I'll be having the integral from minus 2 to 0 of x squared into, let me quickly expand this. S plus 2 squared is s squared plus 4x plus 4 dx, right? Plus this 1 over 8 is outside now. So I have the integral from 0 to 4 over 3 of 4s squared dx. Let me open that bracket. It's going to be 1 over 8 into the integral from minus 2 to 0 of s squared times s squared is s to the power of 4. S squared times this, that's 4s cubed. And this times this, that'll be what? 4s squared dx. Plus the integral from 0 to 4 over 3 of 4x squared dx. So let's integrate with respect to x. 1 over 8 is always outside, so we have integrate s to the power of 4, we have s 5 over 5. Integrate this, it will be, remember, add 1 to the power, 4s to the power of 4, divided by the 4. Then integrate this, you get 4s cubed all over 3. From minus 2 to 0. Let me give it a bigger bracket. Then for the other side, we have 4 is a constant. Okay, so leave the 4 outside. Integrate x squared. You're going to get s cubed over 3. Alright, from 0 to 4 over 3. Everything inside a bigger bracket. So we have 1 over 8 into, let's substitute the upper and the lower limits. Plug in the upper limit. If 0 enters here, it's going to be 0 every throughout. So we have 0, then minus, let's plug in the lower limit. Minus 2 will enter here to give me minus 32 over 5. 4 will cancel 4. Minus 2 to the power of 4 is actually plus 16. Then this is minus 2 to the power of 3, and that's 8. That's minus 8. 4 times minus 8 is minus 32. So I have minus 32 over 5. Then this is plus 4 is outside. I will not just bother to plug in a lower limit in this case because it's going to give me 0. 4 over 3 will enter here. But hold on. Before I will throw 4 over 3 inside, this is s cubed over 3. This 3 can actually come out under this 4. Okay, so I'll be having 4 over 3 s cubed from 0 to 4 over 3. Yeah, it's an integration principle when evaluating the limit of a function. The constant inside can come out, neglecting the limits. So I'll be having just s cubed inside. So if the upper limit enters, 4 over 3 will enter for x. We have 4 over 3x cubed, right? I should be raising it to the power of 3. Before I don't want to write 0 because if I plug in 0 here, it's going to be 0. So let me just leave it like this, raised to the power of 3. So what would this give me? This is 1 over 8. Alright, into 0 minus whatever is minus that thing. So let me just write the minus inside. If I simplify this with my, sorry, this is 3, not 5. This is 3, please. The LCM of 5 and 3 is 15. 15 divided by 5 is 3. 3 times minus 32 is minus 96. Minus 96. 15 divided by 1 is 15. 15 times 16 is 240. 15 divided by 3 is 5. 5 times 32 is 160. Sorry, that's minus 160. Then this is 4 cube is 4 times 4 times 4. Alright, then times the 4 outside. It's now be 4 is about 4. And that is 256. 3 cube. You know this is 4 over 3 all raised to the power of 3. So 3 cube is 27. 27 times 3 is 81. Alright, so let's simplify this. If we do the maths, 1 over 8 is always outside. Minus 96 plus 240 minus 160 will give me 16. Will give me minus 16. But there's a minus outside. So minus will give me a plus 16 over 15 plus 256 over 81. If you do this with your calculator, you are going to obtain a single value. We have 214 divided by 405, 405.
Yeah, you can punch your calculator to verify. So the expectation of x squared, this is the expectation of x squared. So we can simply do the variance and the standard deviation. So variance of x is expectation of x squared minus the expectation of x all squared. And this is already 214 divided by 405 minus the expectation of x, we got it as 5/18. So you square it. So minus this, if you do it with your calculator, you're going to get 731. Yeah, I've calculated this already. 731 all over 1620. This is the variance of x. So that the standard deviation of x is the square root of the variance of x, 731 over 1620. Alright, I want to leave it like this, but there could be a simplified version of it. Remember, I promised to drop a question at the end of the video. This is the question. A random variable has a probability density function f of x equal to x squared plus 6x all divided by 60 for 2 less than or equal to x less than or equal to 5. You have to find the expectation of 1 over x. This is what you are doing. Alright, remember that for a continuous random variable, the expectation of x is the integral from minus infinity to infinity, okay, of x into f of x dx. So I want to see what you are going to do here. Okay, so you will not be integrating over the full real line because there's already a specific interval for this particular question. Go ahead, solve the question and drop your answer in the comment section, okay? And I'm going to review it.